So today we will start our 10th week session. Till last week we solved the problems, and if you have any doubt, last week we solved several important problems also. If you have any doubt in that, please let me know. So today we are going to discuss on the first question. It's continuation of last class what we discussed. The food compartment of an refrigerator is maintained at 4 degrees Celsius by removing heat from its at the rate of 360 kilojoules per minute. If the required power input to the refrigerator is 2 kilowatt, draw a block diagram and determine first one coefficient of performance of the refrigerator and second rate of heat rejection to the room that houses the refrigerator. Okay, so first as usual we have to write what are the parameter is given. So the given T2 value is given, that is 4 degrees Celsius. We can write it as 4 plus 273, it will be 277 Kelvin. Now next one is Q2. Q2 will be 360 kilojoule per minute. That will be 360 divided by 60, it will be 6 kilowatt. Now work will be 2 kilowatt. Okay, we have to find the value of Q1 as well as COP, coefficient of performance at the for the refrigerator. How much? COP we can easily find it. It will be Q2 divided by W, that you can write it as 6 divided by 2, that is 3. So COP value is given. Now to find Q1, we have W is equal to Q1 minus Q2. From that it will be Q1, you can write it as W plus Q2. So it will be Q1 is equal to 2 plus 6, that will be 8 kilowatt. So please go through this problem, then we will go to the next one. Now we can go to the second problem. A heat pump is used to maintain a house at 20 degrees Celsius. The house is losing heat to outside air through the wall at 100 kilojoule per minute. For a COP, coefficient of performance is 1.5. Find the required power input in kilowatt and supply to the heat pump. So in this case also, first let us draw the diagram. So we are going to draw the heat pump. Okay, from the heat pump there will be Q1 energy heat. So high temperature heat reservoir that we can represent it as T1. Okay, that is house. Now QT will be low temperature heat reservoir. You can represent it as T2. Okay, then T1 greater than T2 here. So W is equal to, we can write Q1 minus Q2. Okay, and here house, this one will be surrounding part. Now we know that T1 is equal to 22 degrees Celsius. That will be 22 plus 273 Kelvin. You can write totally 295 Kelvin. Okay, now Q1 you can write it as 1000 kilojoule per minute. So COP of heat pump will be 1.5. You have to calculate the value of W how much, and similarly COP and W. Now from COP equation you know that it will be Q1 divided by W. From here you can write Q1 is equal W is equal to Q1 divided by COP. So that from the question itself Q1 is given 1000 divided by 1.5. So it will be 666.6667 kilojoule per minute. Okay. So if you convert this into seconds, so it will be 666.66 divided by 60 kilojoule per second. It will be 11.1117 kilowatt. So that will be the answer for this question. So please go through it once, then we will go for discuss on the next problem. Now we will go to some theory problems, so which is already in your weekdays assignment. So first question is an energy storage system. Options offer energy alternative to the fossil fuel, meets variable demands without any adverse consequence. Third option stores and release energy simultaneously, and all of the above. So which one will be the answer? The for an energy storage system, it meets variable demands without any adverse consequence. Okay, so that will be option B will be the answer. Now, if we go to the next problem, energy stored in a CAES in the form of, those are already taught different category of this. So, in this CAES in the form of which energy? Potential energy, kinetic energy, pressure energy, none of the above. So, it answer will be C, the pressure energy. Okay, now if in the fourth one, which of the following bearing is used with flywheel in high speed applications? So options are vacuum bearing, mechanical bearing, hydraulic bearing, and magnetic bearing. So the answer will be option D. Option D will be magnetic bearing. So that will be the answer. So these three questions are very important. You will see the theory level questions also, as well as problem part also, like mathematical paper and pen work also. So you should remember such kind of problem. Like problems will give, some cases it will be most of it will be all of the above answers. Some cases one or two answer may be there. It depends. You have to go through the subject part and clear about the options also. Now we are going to discuss about power rate. Okay, so these kind of questions you've already seen in the week 10, week 11 classes also. So that's why I am solving here these type of questions. So first question, the pump is used to lift 500 kilo of water from a depth of 80 meter in 10 seconds. Calculate the power rating of the pump if the efficiency is 40%. Okay. So first we know that force equation, it will be M times G. So that you can write it as 500 times 10. It will be 5000 joule. Okay. Sorry, 5000 Newton. Now you can take work is equal to force F times S. So it will be 5000 times distance is given 80. So your answer will be 4 times 10 to the power joules. Okay. Now what will be the formula? Power is equal to work divided by time. So it will be P is equal to 4 times 10 to the power 5 divided by 10. It will be 4 times 10 to the power 4. That will be 40 kilowatt. Okay. Now you can get the power rating. It will equal, you can write it as useful power divided by efficiency. So that you can write as 40k divided by 0.4. It will be 100 kilowatt. So that will be the power rating for this system. Please go through this problem. We will discuss the remaining problems after this. Now we will solve the another problem. It will be a pump is used to lift 500 kilogram of water from a depth of 80 meter in 10 seconds. Calculate the power at which the pump works. Okay, you can take the value. G value will be 10 here. Okay, so how to solve is the mass is given and the distance is given, time is given, and G value also given. Similar to earlier problem, F force you can write it as mass times G. So it will be 500 times 10, that will be 5000 Newton. So after that you can write work is equal to F times S. So that you will be 500 times seconds. It's S means here distance, so 80. So it will be 4 times 10 to the power 5 joule. Okay, now power will be, you can write it as work divided by time. So it will be 4 times 10 to the power 5 divided by time 10, that will be 4 times 10 to the power 4, it will be 40 kilowatt. So this will be the answer. It's a simple question. It's like you have to know the very basics formulas what you learned in plus 2 and all, but it will be useful for your course also. Now we will go to next one of the important problem. It's a little bit lengthy, but it's related to the Carnot engine. Okay. So the question is, two Carnot engines work in series between the source and sink temperature of 550 Kelvin and 350 Kelvin. If both engines develop equal power, determine the intermediate temperature. Okay. So first we will write. So source, it is given 550 Kelvin. Okay, so first heat engine E1, Q1 will be the temperature and its output work. Okay, now the temperature T2. Okay, now heat engine 2, it will be Q2, here work W, and this Q3 is going to sink at 350 Kelvin. Okay, now here the temperature difference is T3. Okay, these many details we can. Now what will be our T1? T1 will be 550 Kelvin and T3 will be 350 Kelvin. We have to find the value of T2. Okay, so before going to find that, first we will find the efficiency of heat engine 1 and heat engine 2. Okay, that will be eta is equal to W by Q1. You can write it as Q1 minus Q2 divided by Qn. It will be T1 minus T2 divided by T1. So eta 1, you can write it as W divided by Q2 plus W, that is W is equal to Q1 minus Q2. Now W divided by Q2 plus W is equal to T1 minus T2 divided by T1. That from that you can write W is equal to T1 minus T2 divided by T1 times Q2 plus W. Okay, now just solve this. You will get W minus W time T1 minus T2 divided by T1 is equal to Q2 times T1 minus T2 divided by T1. Okay, so you can write W times T2 my T1 is equal to Q2 times T1 minus T2 divided by T1. Okay, so from this you will get value W is equal to Q2 times T1 minus T2 divided by T1 times T1 divided by T2. It will be Q2 times T1 minus T2 divided by T2. That we can take as equation 1. Okay, now in eta 2 case what will happen? T1 minus T means okay, E2 case you can write it as W divided by Q2, it will be Q2 minus Q3 divided by Q2, that you can write T2 minus T3 divided by T2. Now eta 2 will be W divided by Q3 plus W. Similar process what we did in the earlier case. It will be W is equal to Q2 minus Q3. So this you can write it as W by Q2 is equal to W by Q3 plus W. It will be T2 minus T3 divided by T2. From here W will be Q2 times T2 minus T3 divided by T2. So this will be our equation 2. So first now we have to solve these two equation because its power is same, right? So we have to solve this equation and get the intermediate temperature T2. So before going to that, you first please go through these many steps like how we can get the power of each session, like T2, I mean in between HE1 and HE2. Then we will go for the remaining. First please go through this, okay? I'm going to next slide. You can check it this one also. So now from equation 1 and 2, yeah, from equation 1 and 2 we can equate because powers are equal. So Q2 times T1 minus T2 divided by T2 is equal to Q2 times T2 minus T3 divided by T2. So here you can cancel these two and T2 also. From there you will get T1 minus T2 is equal to T2 minus T3. From here you will get T1 plus T3 is equal to T2. So from this you will get T2 is equal to T1 plus T3 divided by 2. It will be 550 plus 350 divided by 2. Your answer will be 450 Kelvin. So the intermediate temperature will be 450 Kelvin. Please check, please solve it yourself this problem and go through that. And if any doubts, please let me know. We will solve it now. Okay. Now we will go to today's last problem. It's related to flywheel. Okay, so I know that sir already taught regarding flywheel, so I hope you all went into those. So we'll solve problems. Okay, the mass of the flywheel of an engine is 6,500 kilojoule and kilogram, and the radius of gyration is 1.8 meters. It is found from the turning moment diagram that the fluctuation energy is 56 kilonewton per meter, and if the mean speed of the engine is 120 rpm, find the maximum and minimum speeds. Okay, so you have to find the rpm values. So the given data, mass is given, it is 6,500 kilojoule, no, sorry, kilogram, every time confusing. Okay, sorry. So the k value is 1.8 meter, and delta E value is given 56 times 10 to the power 3 Newton meter. Okay, now the N is equal to N1 plus N2 divided by 2. It is given 120, so you can get N1 plus N2 is equal to 240. Now delta E you can write pi square divided by 900 m k square n times n1 minus n2. So from just to substitute the values, it will be pi square divided by 900 times 6,500 times 1.8 square times 120 times n1 minus n2. It from this you can cancel all these, and from this you will get n1 minus n2 is equal to 2 rpm, and n1 plus n2 is equal to 290 rpm. From there you will have to solve these two, add and subtract with each other. You will get the value of n1 is equal to 121 rpm and n2 is equal to 119 rpm. So it's a simple question, but you have to know about the formula for delta E and how it's related with n values. Then you can solve this problem very easily. So please go through this. So we solved different problems today. First one, it's related to the refrigerator, normal questions, coefficient of performance and rate of heat rejection. And second one is also heat pump, COP is given, you have to calculate the power input, and we solved 3 theory questions which is already given in your assignments in last week sessions. And next one, we solved a problem calculating power rating. Next one, calculating power also. You have to just remember the normal formulas for this, and after that we solved a Carnot engine problem. It is very important if two heat engines are connected in series, how you have to solve the problems. It is very important. And after that we solved the problem related to flywheel. You have to remember the formula in this and go with that. Okay, so we will meet. We have only two more classes, week 11 and week 12 also. So just put on track and study very well, and we will meet in the next class.